Good morning, everybody. I'm Steve, and my study topic is the circular economy and biocycles within agriculture. So my investor was Horticulture Innovation Australia. So a big thank you to them if you're in the room for your sponsorship and you're seeing merit in my research topic. Some further thanks go to my wife, of course, who I left at home with a 4-month-old baby before I began my journey, and my family for supporting her while I was away. My employees who held the fort in the business while I was overseas, and we had a record wet season, which obviously would have had a few associated problems with that. The Nuffield Australia management team for putting on a great global focus program, which is not only gives us memories for life, but it was hopefully set us up in business to succeed and to go forward. The Nuffield alumni who I travelled with, and national and international, who have assisted with research topics as well. So just a little bit about myself. I am a first-generation farmer. I grew up in suburbia. I've got no tertiary training in agriculture, in business or marketing at all. I developed an interest in nutritional foods and healthy eating in my 20s when I started actually doing sprouting, wheatgrass, broccoli shoots, etc. My earlier years have been spent in the military and in mining. And then in 2012, I purchased 20 acres up in Koah, which is just west of Cairns, and planned to make a go of that and make the property produce so I could transition out of mining. So I continued with my passion in healthy nutritional foods and continued to do the sprouting and got into microgreens and started doing trials in microgreens and microherbs. Microherbs, as you see on the top right, you would have had them last night on your plate, on your entree, main and dessert. So they've become very popular thanks to MKR and MasterChef, etc. So I went out to all the chefs in Cairns, literally face to face, over 100 of them, gave them samples of my product, and overnight had a business. And that was 4 years ago, and we're steadily increasing our output from there. We supply to 3 wholesalers in North Queensland, and we do retail sales. We also supply to farmers markets and food co-ops as well. We also have a sister enterprise that we've invested in, Cairns Exotic Mushrooms, which was just launched end of last year. That's one of my employees who I've helped seed fund. We're doing shiitake, reishi, oyster mushrooms, enoki, lion's mane, wood ear, so exotic culinary mushrooms for the hospitality trade. So my CSC was in the Netherlands, GFP was the India group. We went off to Qatar, Dubai, France, Belgium and the USA. And then my personal travel was Philippines, Indonesia, the US, Cuba and New Zealand. So just some definitions quickly of circular economy. It's also known as blue economy. You may have heard it referred to that as well. So it's a regenerative system in which resources, input and waste, emissions, energy leakage is minimised by slowing and closing and narrowing material loops, and can be achieved through maintenance, repair, reuse, recycling, upcycling. An agrocycle is a fairly new term, and that's the recycling and valorisation of waste from the agri-food sector. So blue economy, circular economy, agrocycles, they're all forms of closed loop farming, closing loops. So some key statistics here from the United Food and Agriculture Organisation by sector. But essentially, overall, what it gives us is a picture of that 30% of food, 30% of agricultural production is rejected or goes to waste before it even hits the supermarkets or the wholesale markets. Here in Australia, the average household per person, we're wasting 200 kilos of food waste per person per household, which equates to 4 million tonnes and to a value of about $20 billion. And then on a global scale, that's about 700 million tonnes of post-consumer waste to a value of about 3 to 4 trillion tonnes. And then crop residue on top of that is about 5.5 billion tonnes, which makes up 13% of greenhouse gas emissions. So how do we plug these waste streams back into the system? So there's a bad example, the worst case example of it, so at the top there. So just stockpiling that waste, which then becomes anaerobic and creates methane. A lot of farmers will push back their waste crops back into the soil, helping enrich the soil. There's limited diversion from waste to feedstock, and if that is the case, it's generally done on a on-farm basis and not traded. Composting has been done with mixed success. There's commercial composting operations out there They're usually aerobic static pile composting systems and not employed on farms in any great number. There's limited anaerobic digestion in this country because we don't have much infrastructure, and the subsidies are not available to us like they are in the US, in the EU and UK. So we face some geographical challenges in regards to managing our waste because all our farms are less intensified, we're more dispersed around the coastline, and our logistics and transport networks aren't as advanced as other countries. So, some emerging technologies and ways to solve some of our waste. This is Hermetia illucens, which is black soldier fly larvae. So its origin is in South America, but it's found worldwide. It's not known as a vector at all for pathogens. It doesn't spread disease like the common housefly, and it's a very suitable protein source for aquaculture, animal feed, pet nutrition, and human nutrition alike. So this is one of the most efficient animals in converting bio-waste into a protein source. So as you can see, in 18 days, 1 gram of that larvae can convert into 2.5 kilos of edible protein, giving us about a 42% protein content and a 30% fat content. So the best use for the soldier fly larvae at this stage is for poultry feed and for the aquaculture industry. The aquaculture industry is growing 10% per annum per year in Australia at this point in time, and the cost of fish meal and aquaculture feed is going up, is over $2,000 a tonne now. So organic waste can be converted into aquaculture feed quite simplistically. The process of turning organic waste into soldier fly larvae is not high tech. It requires what we call bioreactors, but it's just basically raising tanks for the soldier fly to be grown in. I visited a soldier fly larvae operation in New Zealand, and there's now 2 in Australia that have kicked off, who are all doing modular soldier fly bioreactor systems, and they're looking to roll them out so they can be decentralized bio-waste conversion to animal protein, to feed protein. If you thought that the soldier fly was fairly impressive, this is duckweed or lemnaceae, and this is an aquatic weed which is usually found in brackish waters, slow-moving, nutrient-dense waters. It's often mistaken as an algae, but it's actually a plant. And this has a 40% protein content and a 5% lipid content. And duckweed has a dual function. It can be used as a plant protein and can also use in bioremediation. So the bioremediation side of that, it's used in wastewater treatment plants. It can soak up loose nutrients, so your phosphates and your nitrates, and then can be composted essentially. Or if it's not absorbing heavy metals and minerals, it can be diverted into feedstock as well. I visited a couple of operations in the Netherlands where they are growing the duckweed seasonally and feeding it to the dairy cows over there as well. Right. So this grows optimally between 6 and 33 degrees, and there's quite a lot of potential for this to be grown in subtropical and tropical northern Australia. But at this stage, it's only still at the R&D phase. The university's only just looking at it, and no one I know or have found is utilising it in any way of scale in their systems. As a plant protein, it's also very valuable. This is a picture of Parabel in Florida, who declined me a visit, unfortunately. They are just pumping out 5,000 tonnes of plant protein from the duckweed per annum now on their first plant, and that's going all into human nutrition market. So high-end plant protein for all the vegans. So the duckweed has been used in subsistence farming all through Asia for quite a long time, in all their soups and broths throughout Indonesia, Vietnam, Thailand. It's quite a common additive to their diet over there as a protein source. Right. So FAO's identified duckweed as having enormous potential for protein sources in the future. So moving on to some tech. Last year they had the first inaugural the Australian Circular Economy Conference here in Australia. And part of the discussion was in 2050, what's the cost of waste going to be and how are we going to trade it? So there's a few trading platforms out there now. Tridge is a US-based platform which deals in seeds and oil wastage. AgroCycle has been commissioned by the European Commission to manage waste and to trade it. Renewy is another one in Europe which has just done $2 billion in revenue in trading waste. Biotrading is a subsidiary of Veolia, who is one of the largest waste and water management companies in the world. So those platforms are out there now. These platforms have literally only launched in the last 2 years since I've started my scholarship. So the technology and the marketplace for this is moving very rapidly. So onto a couple of farming systems that I checked out while I was on my travels on my scholarship. So in Cuba, I had a visit to the country, which is an eye-opener. So a little bit of history about Cuba. In 1959, Cuban national revolutionaries started to take back control of their country from US-led control. So they nationalized all their assets, banking, manufacturing, export, agriculture. The US, in turn, placed embargoes on them. Fidel Castro, at that point, then went to the Soviet bloc for support, causing a bit of a crisis, as we heard about. But once the Soviet bloc then disintegrated, Cuba was left in the lurch again and had very little amount of imports coming in, which created a large problem for the population, and rationing had to take place. The Ministry of Ag then they started the Autoconsumo plan, the self-supply plan, where they declared that there shall be no uncultivated land in the country. And the Ministry of Ag then made unused lands available to farmers, and gave the current farming lots, gave ownership to the farmers who are currently using farming lots, making it wide open and available to individual growers and the population. So 25 years later, what that looks like is when you go to Cuba, every single neighbourhood has an organoponico or a market. It's a local market. You don't walk down to Coles and Woolies. You walk down to your organoponico and you get all your fresh vegetables there. 0 food miles. It's pretty good. Usually they've got a baker and a butcher co-located, and this provides essentially 90% of their diet. It's simple. It's subsistence, but it supplies. There doesn't seem to be any homelessness there, and it supplies the country with their basic dietary needs. The organoponicos themselves are very simple systems. So they're just using composting systems, worm waste, worm casting systems, and local animal manures for their inputs and fertilisers to grow all their produce. There's very low mechanisation. It is a high labour cost, labour intensive, but the labour is cheap, so that works over there for them. And yeah, essentially, it's the best example of a closed-loop farming operation that I've seen. The benefits obviously go to the community because it's community-owned farming operations. There's local employment. The food's very, very healthy. There's little wastage. And as I say, the general happiness index over there from the people and the population was quite high. So I don't expect we're going to go backwards and apply these to our current Western systems, but it's a very good model for developing nations going forward. Syntropic farming systems is a relatively new term which has been coined out of Brazil. So conventional farming is generally entropic, and it goes from complex to simple, where syntropic is from simple to complex. So this is done essentially by strata-based alley cropping. It requires a good understanding of strata management and careful design through polyculture of crops and ecological succession. The leading figure in this space is a gentleman called Ernst Gosch, based out of Brazil, and he's transformed a 1,200-acre lot of deforested land to the most productive microclimate in Brazil, and he's selling the highest selling coffee and cacao in the country now as part of his model of what he can do. Syntropic farming is now rolling out across the globe, and it can be applied to temperate environments as well, and can also incorporate animal systems to it. So it's basically designed to self-fertilise through ecological succession, is the basis behind it. This is an example of a syntropic alley crop. So you've got your roots and your tubers, you've got like bananas coming up there, you've got timber crops, and it's just it allows a constant supply of revenue for the farmer, and also allows access for machinery for mechanisation for timber, for the timber and for fruit production and harvesting. So, in conclusion, unfortunately, Australia has one of the highest rates of waste and one of the lowest rates of recycling. So we really need to start looking at how to move from a linear resource mining company to a nutrient cycling economy. We can do this by setting up regional bio-waste facilities, incorporating some of the technologies I said before, like the soldier fly larvae and the duckweed, and then we can coordinate that using different app technology, which is now available to us. And Syntropics is also another tool of which we can use to bring into the fold. We need to start changing our language. Sustainable's out. There's nothing sustainable anymore. We need to start regenerating. So we need to start using regenerative agriculture. Okay, so our story on our farm. So our microgreen operation, we currently deliver microgreens to restaurants and cafes. We collect their coffee waste. We take that in. On that, we grow mushrooms. We sell the mushrooms back to the restaurant with our coffee waste. That's mushroom. With our mushroom waste, that's mushroom compost. We then apply that to our syntropic fruit tree alley crops. With our wastewater from our microgreens, we're diverting that into IBCs and we're growing duckweed. Some of that we then divert into compost, and then some of that we're using for feed as well for the chickens. We have a small soldier fly larvae bioreactor, which I use for additional food waste that we have, and that the soldier fly larvae is currently going to our poultry to feed them as well. So we're on a small farm and we're doing things on a smaller scale, but we plan on scaling everything up quite soon. But with 70% of the world's calories coming from smallholder farms, these technologies, I believe, can help go a long way to feeding, the population in the future. So recommendations based to you here in the room. So do a desktop evaluation of your waste streams. See what you can do to reduce, divert, valorise, and trade and repurpose your waste. Download and have a look at a couple of those apps that I've mentioned before. I think they're going to be the eBay and the Gumtree and the Uber of the future. And talk to your NRMs and investigate smart farms grants, waste management grants. The more pressure is there on to go down this path and to adopt these new technologies, the more they'll get up. And in general, just think holistically about your farm and apply syntropic processes and embrace your circular economic principles. Thank you.